Well, good evening, and what you see before you is an array of tiles. I'll come and explain those in a second. What I want you to do is to think back to the videos we've done on ceramics and plastic armors. So what I've done is I've made a bit of a treat for people. So just put these on here temporarily. We have here a variety of common enough materials you'll find around a house. So nothing fancy. Steel 0.5 millimeter, aluminium 1 millimeter, stainless steel 0.5 millimeter, textured rubber, whatever that was, I can't remember, 3 millimeters, yes, 3 millimeters, plain rubber 3 millimeters, resin-impregnated fiberboard. This is actually shingle, roofing shingle, so 2 millimeter thick vinyl tile, quite stiff. Another type of vinyl tile that's a little softer. 3 millimeter thick vinyl tile that's really hard and thick. The leather, we'll come to that in a second because that's not forming part of these tiles, but is going to be part of the testing process. Let's stack these over here because my hands are full. Soft plastic, this is a polypropylene. A thick, hard tile, this actually has a soft rubber backing, it's 4.5 millimeters thick. Our friend Mr. Perspex, 2.5 millimeters, and then 12 millimeter wood board. Well, why am I looking at wood board? Why am I looking at plywood, 6.5 millimeters? Because these are nice and stiff, and you'll see why these feature in these tiles later. Our excellent friend, Mr. Macrolon, other brands of polycarbonate, I suppose, exist. 4 millimeter thick polycarbonate. Then we have 10.5 millimeter thick acrylic as a slab. So those are the basic materials. We have some other materials as well. So we have our classic bathroom porcelain tile, 7 millimeter thick tile with a nice hard enamel surface, good vitreous material. We have some natural vitreous materials as well. So this is 21.5 millimeter thick granite. This is natural granite. This is all the way, yeah, this one's from India. Nice and hard. I don't think it's going to be much surprise if this stops a bullet. What we're more interested in is seeing how it breaks compared to a man-made material, something like this. So I won't give the brand name away, but this looks like stone, but it's actually fragments of stone compressed together with resin. So will it behave like our classic vitreous material, like a granite or even a glass? Will it behave like a tile, or will it behave differently? That's going to be an interesting question. Then we have some another one. This is brick. I can't quite make the brick the same size because of I've got to make sure the holes are out of it, but I took a nice slice of it. 13 millimeter thick brick. Brick is surprisingly soft for a material. So what we've done is then made a whole series of tiles, and I'll go over them all later, but some of them you'll see codes on, others you won't, and that's because each of these materials, like steel, has a letter code on it. So to make life really easy, we're going to letter code the samples so that we can test them. So if we have a look example at sample 23 here, we see our letter code EBE, BEB, EBC. And what we actually have is hard vinyl tile, aluminium tile, aluminium tile, aluminium tile, stainless steel. Those go together nicely, and these will be compressed together and bound with duct tape and then subject to firing trial, because I want to see how they behave. I want to see how they interact with each other. Another one here, this one's going to be slightly different. Here we have a steel outer plate, that's our A, backed with 10.5 millimeter thick acrylic. Then we have vinyl, then resin-impregnated fiberboard, vinyl, fiberboard, vinyl, fiberboard, and backed with aluminium. When all these go into the testing setup, which I haven't finished making yet, part of that testing setup will involve samples of this leather going over the back with another cushioning here to simulate clothing and people, so we can see even if the round is stopped, see what sort of deformative effect there is on the archetypal person who might be wearing it. We have some really interesting ones, which I'm hoping to get some really good stuff out of. I'm not even going to try and read all that to you. You can see it very well. What we have is we have vinyl tile, metal tile, rubber tile, rubber, all the way through, and again an aluminium backing plate. And the purpose of doing this is to see how we interact with hard and relatively soft materials. So some of the materials are picked because they're very stiff, others are picked because they're hard. So for example, a hard man-made material, this is another of that man-made stone, nice and hard outer face, plywood, to give it some stiffened backing. Then behind that we have rubber and polycarbonate. Another example, vinyl tile. This is that stiffer vinyl tile, that relatively soft polypropylene, 15.5mm thick natural granite, and then a nice wood board at the back to make sure that there's no bending. This is extremely stiff. This will either break, shatter, or just be straight perforated. It will be interesting to see how that holds together. All right, one last one, and then I'll talk about how the testing procedure is going to go. So we have our acrylic, vinyl, rubber, fiberboard, rubber, vinyl, and acrylic. And right in the middle of this sandwich here, we'll see, because of the way this is this textured rubber as one of the materials, we actually have air gaps within that, within what is otherwise a stiff sandwich. So that'll be interesting to see how those deform. And there's all manner of these. So these two samples are identical, except on this one we're using a tile as a middle layer, and on this one we're using, excuse me, a man-made, probably not vitreous material, another of these artificial stones. These are identical, except this one is switched with this one, so we get to compare these two layers directly to each other. And the advantage here is these ones are wider than the normal 76mm tile, and that way if we have an edge effect going on, that's not going to count into it. And maybe the last sort of really interesting setup we're going to have is, this is sample 29, acrylic, vinyl, metal, vinyl, metal, vinyl, metal, all the way through, and then backed with a piece of steel. So all of these are going to be put into my testing setup, which again I have not finished yet, and then we'll see the data from that, and we'll have the codes. So because these are all numbered, what you'll have is a string of letter codes and then a success or failure with them. These are not the only ones. There are some unfinished plates as of yet. So these are the unfinished ones. Let's take a break to appreciate how pretty that is, and I'll talk about them. Okay, so in the first part, just to recap, we've made a series of samples out of all this big stack of a myriad of materials. Then I brought out this fella here. So just to be informed as to what we're looking at, what we have is we have a sheet of polycarbonate into which holes have been drilled. These are masonry nails, and although these look different lengths, that's because they overlap on the back. This is just masking tape to stop them falling out, and these overlap here. The idea being that any round that comes in will either meet between the spikes and have to bend the nails sideways, or if I'm particularly lucky, strike the nails head on or partially. And these are masonry nails, so these are nice and hard, and we're hoping to cut the round up. This isn't going to sit as it is. I have yet to make the little bodies to go around this, and this will be filled with resin, so these will not be able to bend very well. So we have a sample specimen of the short nails. Then we have another one, a duplicate of the even shorter ones. Obviously we want to use the least amount of material. We want to be optimal with our weight. Again, the tape is just to stop these falling out of the holes. This will be filled with resin as well. So let's do very short. And this is what it looks like without the tape. So you can see the overlapping pieces of the nails at the back. Turn it over without them falling out. And this is with the longer ones. So we have very short, and long masonry nails. I'll put that one there. I've got to turn it upside down so they don't fall out. And then one final one, again, polycarbonate and very long nails. But these, you'll notice, are a little shinier. They actually move a little bit too much. They won't move at all when they're in the resin. These are actually aluminium nails, which aren't used very much, but they have a particular use. Again, just a bit of duct tape, masking tape, something falling out. Again, the same principle exists. Now, there is a surprising amount of gap between these. If I am unlucky, we will have a direct miss through there, in which case it's only penetrating this much of resin. If I'm particularly lucky, we'll hit. What I'd like to see get out of this, assuming they don't break up, is both a direct impact and then an angled one as well. I want to see what happens to these as a round goes through them, and that's true across all of them. So these still need mixed up with resin yet, and to provide a nice stiff backing, these will be backed with the same 12mm thick wooden board when they go into my sample setup. So hopefully you'll find that interesting. I'm hoping to be surprised by some results. You never know what we're going to find. This could be a complete failure. We could have rounds go through all of them, or, you know, we might find something of genuine interest to talk about. So that's the true nature of experiment. As I say, we've got a mixture, and each mixture I thought about relatively carefully, not maybe too carefully, to give a good sample of how these materials behave. Whether we have vinyls, be they stiff, metals like aluminium, softer plastics, and, you know, how these are all going to behave together in concert with each other. So these will be pressed together, and that alone, well, let's hope that stops around. That'll be really interesting if we can get away without using ceramics or high-grade metals. I have some doubts. This is the one that I'm particularly hopeful for, 19. So let's mark my words later for whether I succeed or not. Where we have our metals, our hard vinyls, and our rubbers as interlayers there. So this could be very interesting. The next step is to post this video, let you have a think about what you expect to happen. I will post the data with it to show you what each one's going to be made up of. And the next video will show the set out of the testing setup, so you can see how these are going to go together. That's it for now. Thank you very much.